In this class we study about the JK flip-flop, and JK flip-flop is a slight modification done in the SR flip-flop. That is, we know in the SR flip-flop we are having two outputs, that is Q, that is we are having two outputs in the SR flip-flop. I just draw the SR flip-flop here, SR flip-flop, SR flip-flop, and we are having the clock pulse also. Say this will indicate it is the positive level trigger, and this we are having Qn here and Qn complement, Qn complement, Qn complement. Just write it down neatly. Then it is Qn complement. It is Qn and it is Qn complement. Qn and it is Qn complement. Now we know this is your SR flip-flop. What we are doing here in the SR flip-flop, if we have 1 1 here, we get a condition, that is either this both output will be 0, either this will be 1, this will be 0, or this will be 0, this will be 1. So this is the condition which we get when the both input are 1. When both input are 1. So in order to avoid this one, we make a JK flip-flop. We make a JK flip-flop by modifying the SR flip-flop. So in order to avoid this one, we go for JK flip-flop by slightly modifying the SR flip-flop. So how the modification is, we name the S with J and K with R, and we have a feedback. We just take the feedback of Qn complement to the J as input, and we take the feedback of Q for K, Q for K. So this becomes your J, this becomes your CLK, clock. So this we call as a JK flip-flop. See, JK flip-flop is similar to your SR flip-flop. Working will be similar, but except for the case of 1 1. So in this case we are getting the unpredictable output, that is this one. So in order to avoid this one, we just cross connect this Qn plus, we just cross connect this value. So if you are not understanding, I will just show you in detail. So you can just see here, I am just cross connecting this one here like this, and see, just cross connect. So this will be your Q, this will be Qn complement. So these two values are complement to each other. But what happens for SR flip-flop, when you give S is equal to 1 and R is equal to 1, the Q and the Qn complement will be equal to 0. So and otherwise it will be equal to 0 and 1. So what happens? So in order to avoid this one, we go for JK flip-flop. So this is next one, we go for the diagram of your JK flip-flop. From there we just see, after writing down the diagram, we just see the working of JK flip-flop. So this will be our JK flip-flop, and we know that we need to give one clock pulse, that is we have given CLK clock here, clock. So this clock will be the positive level triggered, but positive level triggered clock. So in this level, when this clock positive level comes here, then this J flip-flop will work. When this negative level comes, it will not work, so it will be inactive. So say we are having the clock is equal to 0, that is clock pulse is 0 here, and we are not giving any input to the j and k. So what will be the output? Output will be of its previous. It will be recalling its previous. So that is when you are not giving anything, and when you are not giving any input here, and clock is 0, then j is equal to x, k is equal to x. The qn it will be your qn, and it will be your qn complement. So what are the value which it is having? Previous value will be is equal to the next value. So this will be your next stage. qn plus 1 is the next stage, this is the previous stage. So next, if you are giving clock equal to 1, and if j is equal to 0 and k is equal to 0 also, then what happens? Let us see here. When clock is equal to 0, j is equal to 0 and clock is equal to 0, clock is equal to 1, we are giving clock is equal to 1, clock is equal to 1, j is equal to 0 and k is equal to 0. Then 0 complement it becomes 1 here, then 1 complement it becomes 0 here. So 0, 1 minute, I just complete this flip-flop here. Okay, now it's complete. Okay, now it's complete. Okay, now it's complete. So if you give 0 here, then the value will be 0 here, then 0 value will be given to here, then 1 value is being here. So 1 into 0, 0, 0 complement it will be 1. So 0 and 1 for k, j is equal to 0, k is equal to 0, it shows that it is recalling some previous value. So that is, we can take that it will be qn and qn1, and either we can take it as old state or is previous state. It is having the memory state. This we call as the memory state. The previously എന്തെങ്കിലും ഒരു വാല്യൂ ഉണ്ടെങ്കിൽ അത് അവിടെ റിമെമ്പർ ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. Next one, we just see about your giving the value for j is equal to 1 minute. Now we see 1 minute, I just complete this one. Okay, now we just see giving value for k when clock is equal to 1, when j is equal to 0 and k is equal to 1. When j is equal to 0, we know that 0 complement it will be 1 here, and k is equal to 1 into 1, 1 complement it will be 0 here. When s complement is equal, when s equal to here we are giving 1 and 1 complement we are getting it as 0 here. So this 0 value is being given here. 0 into 0, that is 0, 0 complement is equal to 1. That is qn is equal to 0 and qn complement is equal to 1 here. So same thing which we are getting here. Qn when j is equal to, clock is given, when clock is high, when j is equal to 0 and k is equal to 0, k is equal to 1, then we are getting qn is equal to what? Qn is equal to 0 and qn plus 1 is equal to 1. Qn plus 1 is equal to 1. So this we call as the reset stage. Reset. Next we give 1 here. And give 1 into 0 here. 1 and 0 here. Then see here what happens. Next we give 1 and 0. This clock pulse will be high. 1 and 0. J is equal to 1 and k is equal to 0. 1 into 1, 1 complement it will be 0. 1 complement it will be 0. Just draw this one. 1 complement it will be 0. 1 minute, neatly. So 1 complement it will be 0 here, 0. Then the 0 complement here it will become 1. 0 complement here it will become 1. So this 1 will be taken here, 1 will be taken here. So 1 will be taken here. So 0 complement it here, it is also 1, and 1 into 1 1 complement here it will be 0. Here it will be 0. Here it will be 0. 0. We are getting 0 here, 0 in this case, and here we are getting 1 in this case. So 0 into 0 0 0 complement it becomes 1 here. So q1 plus 1 is equal to 1 here, and q1 complement here it will be 0. So that we write down here, q1 1, q1 complement it will be 0. That this stage we call as set stage. Next condition become j is equal to k is equal to 1. When j is equal to 1 and k is equal to 1, when j is equal to 1 and k is equal to 1. So in this condition we need to assume any one input for q1 and q1 complement. Say we have assumed this previous value, that is q1 is equal to 1 and q1 complement is equal to 0. This 0 will be fed here. That അതായത് എന്തെങ്കിലും ഒരു വാല്യൂ നിങ്ങൾ ഇവിടെ അസ്യൂം ചെയ്യണം. k is equal to j is equal to k is equal to 1 ആകുമ്പോൾ ഇത് ആദ്യം നമ്മൾ റീസെറ്റ് ചെയ്തു. റീസെറ്റ് ചെയ്യാന്ന് വെച്ചാൽ, reset means what? If any previous in state is there, that is reset, and by using 0 and 1. Then we are going to set it 1 into 0. The setted value will be permanent. Then this q1 complement will be equal to 0 here, q1 will be equal to 1 here. This q1 value 1 will be given to here. 1 value will be given as a feedback to this to here. അപ്പോൾ ഇതിനൊരു ഫീഡ്ബാക്ക് ആയിട്ട് ഇവിടെ വരും. സോ ഫീഡ്ബാക്ക് ആയിട്ട് വരും. സോ ദിസ് q0 will be given as feedback to this input to here. ഒരു ഫീഡ്ബാക്ക് ആയിട്ട് വരും. സോ ആ ഫീഡ്ബാക്ക് ആണ് 0 വന്നത്, ഇവിടെ ആ ഫീഡ്ബാക്ക് ആണ് 1 ആയിട്ട് വന്നത്. സോ ദെൻ വാട്ട് ഹാപ്പൻസ്, ഇറ്റ് ബിക്കംസ് 3 input AND gate. 3 input NAND gate, 0 1 1, 0 into 1 0 0 into 1 0. So this becomes 0 as the input. Then it becomes 1 1 1, 1 into 1 into 1 1, 1 complement it becomes 1 complement it becomes 0 here. So next one we are getting 0 complement as the 1 here, and here we are getting it as 0 here. Here we are getting as 0. This 1 complement makes what? The output as 0. This 1 complement makes the output as 0. Output as 0. Then 0 into 0 it makes it as the output as 1. See, we are given q1 complement is equal to 0 as the feedback. Then what happens? After giving that, the q1 value will be changed. q1 value will be changed to 0 0, and this value will be changed to 1. This value will be changed to 1. Afterwards we are giving the same value, q1 value as 0.